Please share the last problem.
Yes. Let's start off with today's problem. I will be giving that problem in the group again. Fine.
Okay.
Yeah. So I will be starting off with this. Just a minute. So let's start off with this. This question, generate parenthesis. How many of you have solved it earlier? Giving this question in the chat box. Okay.
Okay.
Please go through it. Try solving. Take 5 minutes to think how the problem will be solved. Take 5 minutes. Correct? Then we'll discuss. Think for 5 minutes. Then after 5 minutes, those who can think of the solution will tell me. Okay? Till the time I'm muting myself. Yeah. Any inputs I can get from here? What are you thinking? How you will be solving it?
Sir, initially we can generate a string of opening and closing brackets of n opening and closing brackets, right?
Yeah.
Then we can possibly generate all combinations of the string, like all combinations of opening and closing brackets. Then we can like check for the valid case and add it to a result.
Can be done. How would you generate? That's the thing.
Okay, so sir, we can possibly use recursion, like we can take one opening bracket and then node take. We can generally use the like technique of take and node take value.
Yeah, sure. Okay. Apart from this, any views anyone has? Just let me open the board. Hello.
Yeah, you are audible. I'm not able to think.
Hello.
Yeah.
So I was thinking that we will have a two recursive call, right?
What
So
kind
one
of?
for taking that bracket, and one for not taking. And when we get the output, the sixth bracket and all are in the form.
Okay. Let's say we have to place for n equal to 3. We have what kind of configuration? Something like this, right? 3 opening brackets, 3 closing brackets, something like this. And we have to get what? We have to get what? What kind of configuration is required inside the problem? Can anyone tell? What is being said inside the question?
Like pick and unpick.
Closing in the
Generate all combinations of well-formed parentheses. What does that mean?
opening and closing bracket.
No. What does this line mean? Generate all combination of well-formed parentheses.
That
Sir,
means the
we-
valid,
we
valid,
can-
valid,
Valid parenthesis.
Okay. What do you mean by valid? What is valid?
First opening, then a closing.
No, nothing as such, right? First opening, then closing. Let's say then opening, then closing. Is it valid?
No.
No, it's
No.
not valid.
It's not
What do you
valid.
mean by
First
valid? What do you mean
Number
by
of
valid?
number of opening and
Number of opening equal to number of closing brackets.
So if I reach the end,
Yeah.
if I reach the end of any string that's given here as valid, what will happen? I will find that if I reach the end, I will find that all opening brackets have been satisfied by a closing bracket. Am I right?
Right.
Right? That is the meaning of valid, right? If you go till the end, at the end point, you will get there are no opening brackets that has not been satisfied by a closing bracket.
Closing bracket.
All opening brackets have been satisfied by a closing bracket. Now next, how should we do it? How should we proceed ahead? Tell me the best approach. How would we proceed ahead in the best manner? What can you think of? That's why we are here today, right? So, okay, let's maintain a count. Let's maintain a count that what is the, till this point, let's say I have placed X number of brackets, X number of opening brackets. X number of opening brackets I have placed right now. So let's have the count among these X brackets. How many opening brackets have not been satisfied yet? Let the count be B. Let's say B opening brackets have not been satisfied yet. Then what can be my choices? Tell me. After placing X brackets, let's say I have B brackets, B opening brackets that have not been satisfied yet. Now what can I do? Now what can I do?
We can
What
take
are my choices here?
we can take B closing brackets.
So what
Okay.
you are doing here, you are placing now the X plus
1.
1. This bracket you are placing right now. Now what you can do here? Tell me that.
We can take or not take, I think. Something.
Sorry.
We can take a closing bracket.
You are given two choices here, right? You can either place a opening bracket, you can either place a closing bracket. That's it. Am I right?
Yes.
Something you have to place, right? Something you have to place. But how will you place that? What are the conditions? That's what I want to know. What are the conditions?
Sir, if there is no opening bracket, we cannot have a closing bracket.
Exactly. If suppose at this point, there are, if B is 0, then as per the well-formed notation, right? Well-formed parenthesis, what does it mean? That at the end, definitely all opening brackets will be satisfied by a closing bracket. What's next? At any point you go, can you find that, okay, any non-well-formed is there, non-well-formed parenthesis is there. Suppose that like this. We are having a closing bracket here that does not satisfy any of its previous opening brackets. Such kind of non-well-formed structure. Are we able to find here? No, right? So at any point of my string, you won't be finding that, okay, this particular closing bracket is being placed and it is not satisfying any previous opening bracket. That's also not possible. Correct? Now tell me what we can do. What are the conditions? If suppose the number of opening brackets is 0, I cannot place a closing bracket now. That's a condition. You cannot. We have just one choice based upon this. We can just place a opening bracket. Am I right? Am I right?
Yes, sir.
Next what? Next what we can do? Next, if suppose B is greater than 0, what are the conditions that are possible here? Can you tell me?
Sir, if there are open brackets available, we can put an open bracket, otherwise closed bracket.
So we can either put an opening bracket here and increase the count that we have now B plus 1 number of opening brackets. Am I
Okay.
right?
Right.
And next, either we can
Closing bracket.
place a closing bracket and say we have now B minus 1 number of closing brackets. Sorry, opening brackets.
Opening bracket. Okay.
Next what? We have to check one thing, right? Before placing an opening bracket, what you need to check? You have to check something. What is that?
Whether it is end of the
Whether
parenthesis.
I have already placed in brackets or not. Am I right?
Yes.
Yes.
If you have already placed in opening brackets, you cannot place n plus 1 opening brackets. That's not possible. That's the
Yeah.
thing you need to check. Now tell me, can you code it? Can you code it? How many of you are willing to code it now? Would you code it? Try for 5 minutes? Or should I code it for you? Tell me that. Hello?
Yeah, please code slowly.
Okay, is my screen visible properly to all of you?
Yeah, visible.
Let us try to code it. Okay, fine. So I will be taking a helper function here.
Okay.
Correct? C++ is the language. I will be taking a helper function here that will be returning a vector only. Let me have some thoughts here. What we actually want to do. Any ideas you can think of? How should we start off?
We'll pass the solve helper function with the in and Opening and
Let's say
bracket
we're
0,
having
0.
generate parenthesis helper. This is my function. That is having first one. How many opening brackets we have? Pending opening brackets, right? How many are open as of now?
Close.
As well as we can have
Close.
90 and this particular thing we need to have. What's next? Anything else we require?
Close bracket.
What is the string I am generating? Am I right? Close brackets are not required because we can already determine that via the n, right? The variable n. What is the string I am generating? That's what we
Okay.
require. Next, what? Next, what? And we need to return something, I guess.
List of string means vector of string. We need to
A
return.
vector of string we need to return, right? Next, what we need to do?
Sir, if our open is equal to n, then this is the base case.
Yeah, that is one of the base cases for us. So firstly, let's handle if suppose open is 0, then what we can do?
We can have a opening bracket.
So open is 0, right? Tell me for one thing that let us approach it in some other manner. I will say, let us make it void. And inside the public section, I will be doing one thing. What is that? I will be keeping a vector of string as my answer, correct? That will be much helpful for us. Okay, fine. Now what we should do? If suppose my open is also 0, right? If my open is 0, then what are the conditions you would like to employ here? There are 0 opening brackets in my case as of now.
We can put
Place
open
the
bracket.
opening bracket and increment the counter.
Okay, firstly, let us check if n is also 0 or not. We have exhausted all our needs, right? Open has also been exhausted. N is also exhausted. No more can be placed. And whatever where there have been satisfied. That means our string is complete. Let us push that into where? My answer vector. String is pushed. And we can return from here. Next, what? What else we require? Tell me.
We will put an open bracket and move forward.
Okay, so what is the condition for that? If, else if
If it's open plus generate.
n is
greater
greater
than
than
0.
0.
Yes.
What
Yeah.
we require?
Then we can increase the opening bracket. Means open.
Okay, we
We will
can say
recursively call
generate what? Generate
open
what?
plus 1.
Yeah, there is no
This
there an helper. Generate parenthesis helper.
open
Of
plus
what?
1.
Open plus 1.
We'll
and
be
n,
saying open plus 1. We'll say n minus
N
1
minus 1.
and
A string open.
so what? Let us do one thing. We have the string already. What we need to do here?
S plus open bracket
S plus
is
equal to
open
an
bracket.
open bracket. Okay, given. Now next what? And
S.
we gave the S as it is, right? Now next what? Anything else we can do here? No, right? This is
Comma.
it.
Comma. Yeah.
Anything else we can do for open equal to 0? That's not possible, I guess, isn't it? Next, what we require?
Closing bracket.
Else, what we require? Two scenarios we have handled. Now, next what?
Here initially open will be what? It will be equal to n, or how it will?
Initially, open will be 0.
So if initially open will be 0, then it will go into if.
In other cases, we can like also like close the bracket. And we
Let
can
us do
decrease.
one thing. Let us initially call the generate parenthesis helper. Right from here so that you get clarity. Initially, no string has been pushed. No opening or closing bracket has been pushed, so we have 0 number of opening brackets, isn't it? N
Yes.
opening brackets has to be placed and satisfied. What is my?
Null.
Let there be an
Null.
empty string. I think
Yes.
that's sufficient, right? And at the end from here, we'll be returning whatever is my answer. That's all.
Yeah.
Isn't it? Inside the function, we can access our a public variable. Now, next, what we require. If suppose, else if we have a condition, else if open is greater than 0, right? Then what we require?
Okay, sorry.
Open is greater than 0. What you require?
Then either we can close or we can increase the, like we can check the
The first one thing.
whether open is less than n or not.
Yeah, first let's see one thing, whether we have any pending value of n or not, right? If we have some opening brackets left to be placed. Now what we can do here?
Then we can generate parentheses and then open +1 and n minus 1.
Yeah. We can have a choice of just going with open +1, n minus 1 and given string. Now next what? Else. Else we can do this as well as we can have another choice as per this. What is that?
So s equals to s plus and then like closing bracket. That thing we need to perform.
Open,
And
right?
then
If this is true, we will be performing this, right? We can have definitely one more thing. What is that?
We will add the close bracket and
we can use the closing bracket. So
and open will be
minus 1
remain
and
same.
n plus 1. That thing.
Okay,
Open will be remain.
any condition that, okay, fine. So we can have definitely open is greater than 0. We can call this function with what? By a closing bracket. And we can say
closing.
open -1, next
n plus 1.
yn plus 1.
N plus 1 way.
Yn plus 1. N will be remaining as it is, if I am not wrong, right?
Yeah.
We are not, n is for what? The number of opening brackets we have right now, right? So that we are not exhausting at all. We are just keeping what? Among this n, I can have a opening bracket inside my current string.
Yes, I
If
got
I'm
it.
not wrong. Yeah.
Yeah.
Now
We
next
need to
what?
check the condition.
Yeah.
Okay.
Whether open is equals to 0 or not.
Yeah. So
And
open
we
is
will-
already greater than 0 right now for us.
We will not put the close bracket.
Sorry.
We will not
Yeah.
put the close bracket and then
Okay. Yes. Yeah. You're correct. What we will do is, sorry.
S
Have
equals
we
to
missed
plus.
something here, right? Something we have missed here. What
S,
we have missed, but
S plus open.
S plus equals to opening braces.
yeah. Next what? Next what?
There is S plus equals to closing braces.
Okay.
It should be in the else, I think.
It shouldn't be in the else, I guess. N is greater than 0. This is getting checked for what? If we can place a opening bracket or not. That's
Yeah,
the
else no need to recall because
in any
condition is
case,
false,
in
then
any
it
case,
will
we
go
can
to
do
else.
that. Whether this is possible or not, that doesn't matter. We can definitely, if open is greater than 0, you can definitely satisfy an opening bracket. Correct? So here, what we are gonna do, we are gonna just place a closing bracket.
Yes.
Now next what? Anything else we are left with?
No.
I guess no. Everything is done.
We
Please
can
check
remove
here.
the else now.
Yeah, we can remove this else.
Amazing.
Anything else? Please see everyone and check whether we have missed something or not. Please check that.
And we need to return the vector of string. No?
And this function is doing that for us. We
And
have a
the-
separate helper function, I guess.
So basically we will open whenever we will open, we will bring, minimize the n by 1. And otherwise we will retain the n at same position. Right?
Yeah, whenever you open, actually,
Yeah.
there are n number of opening brackets only that you can place. So you are minimizing it here. Right? Whenever you are
Okay.
placing an opening bracket, you are minimizing the number that no more can be placed if it is turning to be 0. So at some point you have to check, right? Let me try running it, whether it is running or not. Let us see what has gone wrong. What do you think? What has gone wrong in our case? Extra brackets are coming, if I'm not wrong, right?
Yeah.
Isn't it? Is it?
Yeah.
Yes, extra bracket. Are coming.
How can we just fix that? Any idea? I think what is happening, see, whenever you're trying to handle this case, our S is getting already updated here. And what is happening? Sometimes what will be happening, both these functions will be called, if I'm not wrong, right? Both the conditions are true. If n is
Yeah.
also greater than 0, as well as we are placing this. We are already updating it here once, and then it is getting updated. But this should be a separate call, right? Just when I have utilized this string, this should be a separate call. As per the value, what I can do, just let me write. What I am doing here, see, why I am going wrong. Suppose that my current situation is like this, S is something like this. Now this situation is correct, right?
Yeah.
Let's suppose n is 2. This situation is correct. What will be happening here? I am doing this now after generating all possible strings using this category. When it comes back here, what happens? We have already updated the string like this. Now what should happen as per you? From this position, I will be getting something like this. And then based upon this, I will be, this I didn't require. I just required, okay, I will be satisfying the original string with a closing bracket. Not something like this. I didn't require that. So what should we do in that case? What should we do? What do you think? We are just having an extra opening bracket while calling this function. So what should we do? Tell me that. What do you think? What can be done? Okay, just one try.
When we are returning, we will remove that open bracket.
Let me do one thing. Let me just try creating a copy of this, like something like this. If I just create a copy of this here and I remove this, I am not updating it directly. What I'm doing is I'm just trying to create a copy like this. Let's see if it works or not. And then I update the string and call this function, something like this. Let me try that. Okay, it's getting accepted, right? We just created a copy. Not updating the original string, but just create a copy like this. C++ is a little bit tricky in these cases. Correct? And then you do, for the second function call, you do what? You update the original string and call it with this configuration.
So what's happened? So basically, I'm a bit confused. If you can, make a binary recursion tree.
Yeah, I'm getting. Let me try running this. Whether it's okay. So that has got accepted. Successfully done, right? Do you have any problem with the approach? We are just messing up with the code initially, correct? Let's go with the version n equal to 2. What happens here? Fine. And okay, what we were doing, why it was getting recursion tree will give you just a, but the code will not work as per the recursion tree. So it started with an empty string, right?
Right.
Let's suppose n is equal to 2. What happened then? Can anyone tell? Based upon our code, what happened?
First open bracket.
Let me just do one thing. Okay, let me paste it here. Are all of you confused with the code? Please tell me that. How many of you are?
Rahman, I tried with Python. I got accepted. And
Yes. Who is telling that?
Saurav.
Yeah. Is it getting accepted, right? Then it's fine.
Yeah.
There is no problem on that. Okay, the code is visible to everyone?
Yes.
Okay, fine. Let's go ahead. This is C++ based. You can have different implementations in Python. What we tried here initially, tell me that. This was an initially empty string, then let the value of n be 2. Okay, then what should happen? First condition, check.
Open
Initially we have open is 0, then
n is 2.
N is 2. Next, something else.
It will come to the else condition. Else.
Yeah, this was an empty string, right? Empty string we have like this. Now next, what will happening?
It will come
Open
to the
is 0
condition.
Open is 0, right? Open is 0. This is true. So I come inside the condition. N is 0? No, N is not 0.
No.
So it will be coming inside this condition if I am not wrong.
Yes.
Yes. Then what will happen? N is greater than 0. So what will happen?
Then S equals
With
to S
this, I
plus
will be
2
doing what?
braces.
With this, I will be doing what?
Opening braces.
Yeah, I will be just giving a opening bracket. Then what will be happening?
We are calling the recursion. Like
Okay. Then from here, something will be happening. This is a new
open
function
equal-
call. Then,
open equals to 1.
so for this function call, what are the parameters we are having? Open is 1.
And N is 2. N is 1.
Open is 1. N is 1. Next. And the string is this. Yeah. Next what? What will happen? So now open is not 0 and we have open is greater than 1. So for this function call, it enters in this code block, if I'm not wrong, right?
Yes.
What will happen? N is greater than 0. See,
One more open will be added.
N is greater than 0, right? This condition is true. So what will be happening?
One more opening will be added.
Now see what happens here, right? This
Yeah.
was the original string I'm having, isn't it?
Yeah.
I'm just creating a copy of this. I will not update this, right?
Then it will again opening braces. Only
Yeah,
one
I will not
opening
update this because for this function call, the entire value of S will be changing then if I update this. So I created a copy and sent for the next function call.
Okay.
Correct? And
so
I
then
say,
your S
okay,
will be only one opening braces.
I say that, okay, now a copy like this will be going for the next function call. Original string won't be updated. Correct? It will be
Yes.
remaining as it is so that we can have further function calls with the same value. Getting my point?
So even though we copy it will not affect the upper, upper
Why?
node.
Why? If I am
Because
inside this
we are
code block,
copying down. Huh?
we are doing what? We were initially saying S plus inside this code block, we were utilizing what? S plus equal to this and opening bracket, if I am not wrong.
Okay.
So this is getting updated, right? Already this thing is getting updated. With this, right?
It will update that particular string.
Then what will happen? This function will be called, right? This function will be called. Then what we required this particular parenthesis, but we have now this has already been updated. Now you append a closing bracket here and call for the next function call. So that will never be accepted.
Yeah.
Isn't
Because
it?
it is recursive call, so we have to start from the
We
top of the
require a recursive call something like this, but we are getting this like something like this. Why? Because we have already updated the original string here. How can you expect the correct answer?
Understand.
This is the main thing of C++. You need to take care of whoever are coding with C++.
It is also same as Java as well.
Yeah. Now what will be happening? Tell me, what should we do? Now since I have just made a copy, even if you don't require to see, I am just simplifying it for you. Never ever update the ever string, your original string. Never do that. Always create a copy and send for the next function call. Correct? You don't need to do this. Never do this. Okay? Just work with copies. So what we will be doing, we'll be just removing these such kind of things. Wherever we are just accessing the function call original string and updating its value. That's not required. Correct? Let's not do that, and let's work with inside the next function call, whatever we will be doing, that will be with copies of my current string.
It will be opening braces.
Yeah. Okay, sorry. Correct. Now what we should do? Let me try submitting this and see whether that works or not. I guess this will definitely work. There is no problem on this.
Yeah, it will work. Because initially it was empty, so it took only one single parenthesis.
What is happening? Yeah, it works. Correct. Now, okay, let's come to the dry run. What will happen next? Tell me. What will happen next?
Okay.
From here, okay, I reached this point.
So open equals to 2.
Now open becomes 2. Next.
N becomes 0.
N becomes 0. Now what will be happening? What function calls will be made?
The last function called the closing bracket one.
What will be happening? So again, we have not open to be 0, but this inside this code block will be entering for this function call.
Last function will be called.
So this is not true. Now we have to just call this last function, right?
For closing braces.
What will be happening? It will be calling for
closing bracket.
with one closing bracket we have called. Yeah, we made a copy of this string, passed on to the next function call with some changes. What was the change? We just added a closing bracket. And for this function call, what we are left with? Open is 1 and n is 0.
Again, one another open like.
Okay, for this
So-
function call again, we'll be
Again?
having, for this function call again, we'll be having this execution.
And open will be 0.
And now open will be 0.
Will be 0.
Open will be 0 and something like this we have attained. Now open will be 0 and what will be happening?
It will be base case then, and it will return the
And
answer.
n is 0. So inside our answer vector, we are just pushing this string and we return from here, right? We return from here to the previous state. Anything else that can be done from the previous state? Okay, only one state was achievable from here, that is this. And it returns to the previous function. Now what should happen? Anything else we can do with this? No, right? Any more function call with this cannot be done. So it returns to the previous state again. Now what we are left with? Once we are inside this state with two opening brackets, what we are left with? Can we do something with this as well? No, right? Whatever where the possibilities have been exhausted. So it returns back to the previous function call. What will be happening? Now what will be happening?
It will go for the close bracket.
Okay. It was waiting at this position. It was waiting at this position. Now it will try exploring all the possibilities that we have by appending a closing bracket. So we have something like this. And again, it gives me that number of opening brackets is 0 and n is 1. Right? Now from here, how many states are possible? Tell me that. What will be happening? So for this function call, we will be again entering this block, if I'm not wrong, isn't it?
Yeah.
Yeah, and then yes,
And this
yes.
block, inside this block, this condition will be executed. What will be happening?
We will put one
Opening
opening
braces, it
bracket.
will again start opening braces like.
So it will again append what?
Open
A
bracket.
Opening
opening
braces.
bracket. And for this, what will be happening? Open is
with
1,
-1.
open is 1 and n is 0. Now, what is left here? For this function call, what is left?
Closing braces.
Closing braces.
Huh.
Only one condition, right? Open is also, this will enter this block. Open is also 0. And what's next?
And it will come to the last function.
Yeah, it will just call this function, right? Because n is not 0, so it will call this function.
Yes.
So for this, what we are left, so this is again has reached a base case. We will push that into the vector. My answer
Yeah.
vector that I have kept. Okay, next what should happen? Come up with the solution. Tell me.
Again, it will come like
Right? No more solutions with this
We
state
can
will be
back-
possible apart from this. So it directly goes back here. Now what should happen?
The second recursive call.
Is it possible?
No.
It goes back to what? This function call again. So whatever were the possibilities we have exhausted, isn't it? Have we done it with
Yes.
this call? What are we left with?
One single open and close bracket.
So are we already done with all the possibilities here? Check that. Anything else we can do? No, right?
No. Yes.
Right? So yeah, our solution is perfect. Okay, can you tell me? I think Himanshu was telling the initial approach that we will try generating all possible solutions and will extract the perfect ones. Am I right? That's something like this. This we have done. Then what? Let's say something like this. Then something like this. All possibilities we will be generating, and what we will do? Tell me. And from here, whichever were perfect ones, we'll extract that. This is what initial approach was correct. There is no problem. How this approach will be made? Can you tell me? Initial string, what you do, you have two choices.
One is
Append-
take, another is not
append.
take.
Append this or append a closing bracket. Then from here, again, two choices. Append this or append a closing bracket.
Closing this.
Okay, again from here, two choices. Append this and do what?
Another opening braces.
Okay, so two are already exhausted for us, right? N is equal to 2. So we don't have any
Okay, for
opening
two
brackets
opening
left.
braces.
Only closing bracket can be given here, and again a closing bracket can be given here. So, okay, fine. Now from here, again, what can be done?
Then yeah, closing this, and then yeah, it should not be possible for opening,
Yeah.
I think.
One for closing, another for again a closing, right? This is a not possible solution will go inside this branch, right? Now you do what? All are exhausted, only one possible choice you have, that is this. One solution again we have got. Now from here, what will be happening? You will be left to just one solution. Only one opening bracket can be pushed here. One solution,
Yeah.
this. Anything else is possible? No, right? Only one solution from here.
Hmm.
What's next? From here, we can have several things. Two things again, I guess.
One opening, one closing.
Yeah, one opening, one closing. Oh, let me have it like this. One goes like this, another is two closing. Now from here, what are we left with? Again,
One opening, yeah, this one.
one opening, another is
again closing.
a closing,
Yeah.
right? Okay. So,
Yes.
what we are doing actually here, can anyone tell me?
We are generating all possible.
Yeah, we are generating all possibilities. Am I right?
Yes.
And in the previous approach, what we have done?
We are generating only necessary parentheses, value,
Yeah, we
value
are-
parentheses.
So as per the previous solution here, extra function calls are there. If I'm not wrong, isn't it?
Yeah.
Extra function calls. So are we cutting this off? Can you tell me that? Suppose that this entire branch solution will never be accepted. So I have cut it off. Am I right?
Yes.
I will never start off with a solution that begins with a closing bracket. I have never done that in the previous solution, if I'm not wrong.
Yeah. We have not started with the closing
Yeah,
braces.
such kind of branching is never possible. Now next, you see a branch here, something like this. Okay, not like this, something like this. We have again cut these things in our previous function calls. So if I try to generate all possibilities and if I cut some branches, what is the difference between them? Can anyone tell me that?
Time complexity.
Yeah,
If you take
definitely.
less spaces, less memory,
Less space,
less
less memory,
time.
definitely. Less
Less
time
time.
as well. So what,
Optimized.
yeah, optimize. What is this called and what is this called? Can anyone tell me?
This is brute force approach.
Yeah, this is brute force or exhaustive search. You search out all possibilities. Exhaustive search. And what is this?
This is optimal solution.
This is backtracking.
Okay.
You cut off the branches. Right? If I go to a solution which is not feasible, I will backtrack. Will not ever try exploring all the paths from here. Never. I will backtrack to the previous state and will try exploring better solutions from here. That is what we call backtracking. Okay, tell me now. Are all of you satisfied with the solution, what we have done here? Anything you have doubt, you can tell me.
Almost, I have a doubt. Can you please diagram it by like based on the input 3?
Sorry?
Based on input 3, like can you please do some little bit of diagram?
Input tree as in, sorry?
I'm telling you like diagram it based on input number 2, means n equals to 2.
For n equal to 3, it will be a big tree for us, right? That's why I'm not
Yeah,
writing.
very big.
Okay,
Very
I'll try myself.
Okay, yeah. You try it, you will be getting perfect solutions. Okay, anyone requires the code?
One question,
Yeah.
in naive approach, even how we will, what will be the base condition to, we need to write something, because even if we develop the string, how we will check that it is valid or not valid?
So inside the naive approach, what you are going for, right? here, whenever you see come to this condition, here the base condition all does one thing. It says you that, okay, we have got a string at least. That's what backtracking means. It will definitely give you some optimal solutions. This will only explore those solutions which are optimal. In naive solution, what you can do, you can generate all the strings and check whether they are balanced or not. Yeah, you can, after generating, suppose that both the number of opening and closing brackets have exhausted. You cannot place any bracket more. That means I have reached a state where my string is at least complete with the brackets. Now I will check whether this string is balanced or not. If it is, I will count that as my answer. Else I will not. This is quite. So what is happening? You are, for each state, we have two choices. So if we had to place in such brackets, we will be left with 2 to the power n such states. And for each state, you have to check for 2 to the power n such states, you have to check in the worst case of string 2n, right? This is 2n. You have to check what? Whether the string is balanced or not. So the overall time complexity in those cases goes up to 2 to the power n into 2n. Correct? We don't check anything here.
Yes, yes.
Don't check anything here, right?
Yeah.
Just
So
again. Yeah.
basically the difference between these two is like in this we already know that whatever solution we will get, that will be the answer for me.
Yeah. That
And
will be
in
definitely
that,
optimal.
yeah, and in that we need to add one last check.
Yeah, definitely. That's the brute force approach, because brute force gives you all possibilities. Maybe or may not be in your view. You can take them as well as you may not take them.
Okay.
See, the time complexity here as well is 2 to the power n. There is no difference in particular difference in exponential nature. Correct? Because what we are doing, we are just cutting off some solutions. That doesn't change the time complexity. What we have done, suppose that from 2 to the power n, I have cut off half the solutions. Half of the solution I will not take because they are not optimal for me. So what are left? 2 to the power n divided by 2. So we are effectively generating 2 to the power n minus 1 solutions in the worst case. The time complexity doesn't change for that. It's effectively the same. That's why you are given here what? You are given here what? Have anybody tried exploring the constraints that it is never greater than 8? That's why we have got our solution correct here. What is 2 to the power 8? Can anyone tell?
256.
256, right? And this amount of solution is feasible for us. This amount of solution is feasible. You are doing what? In the worst case, you are generating 256 different data sets. And that is fairly lesser than 10 to the power 8. Am I not, if I'm not wrong? 10 to the power 8 maximum operations you are allowed to do in 1 second. And that's the basic limit for all our solutions. Correct? Any doubts anyone is having? Or am I going too fast? What is that?
No, I have doubt that is the approach of brute force is also 2 power of n.
Yes,
Fine.
that will also be 2 to the power of n.
What will the
Brute-
time complexity for this?
2 to the power n, I said, no?
2 to the power.
Yeah. You just generate the tree and try that how many solutions are coming up. That will definitely be 2 to the power of n. Just it's that we take half and we left half. That's the thing. Any doubts anyone is having? Please tell.
Is there any mathematical formula to, if we are given an n, can we guess how many good parentheses can we generate, like without doing any backtracking and dynamic
I
programming?
don't. This is a combinatorial. Yeah, there is a mathematical formula for this. How many, if you want, there is a mathematical formula. I need to find that out once.
Okay.
Yeah, how many balance? This is effectively how many balanced parentheses we have. So we can check that. Some amount of combinatorics will be coming up with this, correct? First, everyone tell me, have you understood the solution or not? Or you are having any doubt?
Clear, sir.
All of you? Please tell.
Yes, sir.
How many balance parentheses? So find the number of Catalan number. Yes, this is found out by Catalan number.
Okay.
This you can see, and I'm giving you here in the chat box. Where is it? Sorry. Everyone can find it, that number of valid parentheses for a given expression, let's say. This is governed by a Catalan number. Any doubts anyone is having? Please tell me. Please tell.
No, no.
Let me just check what we have. Anyone? Have you got any doubt how we have solved this question today?
So the difference between recursion and backtracking is like in recursion we follow all the approach.
It's not about recursion and backtracking. You're going wrong. It's about brute force and backtracking. Both are involving recursion.
Okay.
Both are involving recursion.
Then how I will get to know that this is okay. So
Both are involving recursion. Ponder upon here. Both are involving recursion. What does that mean?
then okay. Then okay.
Both are having implementation in terms of recursion. I am inside this function. I am calling it again for generating a solution. Same is the
Yeah.
case for what?
Then how is the backtracking?
I am cutting off useless function calls. That is what we call backtracking. Recursion is what? The way we implement backtracking. It has nothing to do with backtracking. You implement backtracking in terms of recursion. There is no relation between backtracking and recursion. How you implement backtracking in terms of with the help of recursion. Recursion is just what? Function calling itself. Same kind of recursion we can again go and implement for generating brute force solutions.
Okay. So if someone gives the problem, how will identify that we can solve it via recursion or backtracking?
Again, you are going wrong. That's what I am saying. The backtracking
What?
means
What here, what I got to know is like backtracking means only it will be a optimal approach, avoiding the useless solution.
yeah. So does it says that it will not employ backtracking? Sorry, recursion.
Yeah, it will.
This is a backtracking solution only, and this has recursive calls in it.
Okay.
So backtracking, to implement backtracking, right? To implement it, you have to do it via recursion.
Okay, so every backtracking problem we can
be
do
solved using recursion. Can be solved using recursion. That's all. You have to think of an optimal approach that I have this possibilities. But if I go to this possibility, it is useless for me.
Then in that case, we need to.
For those are the things what we have, why we are keeping cases here. In what case we'll do what. Is it clear for everyone? Okay, you require the code, right? Hello?
Yeah, audible.
Yes, required.
Yeah, I'm giving it here over the chat box. Please take it. So that's why you got the link late today, because I was just buying the subscription for Zoom. I initially tried with Google Meet, but they are actually asking to have some domain and everything to be bought. And that's why I carried ahead with Zoom.
Okay.
Okay, fine. So I guess, okay, I will get back to this Catalan number in the next class for one thing. Okay, any doubts with this question, or we can go ahead? You can check the discussions here as well. Fine.
Yeah, we can go ahead.
Yes. Would you like to try this word search?
Yeah, we'll try.
Yeah. We have to give it in the chat, right?
Yes, yes.
Given. Please see this. Okay, I would like to ask one thing. Is there someone who is tracking all the codes for us? Means whatever we have solved till now, you have codes for every of them.
No, nothing such like that.
Okay, let me do one thing. I'm creating a doc. Fine. I will be pasting the code and everything there. Correct?
Okay,
The
fine.
question, with the question link. Correct? Let me stop the share and you can focus on the question. Till then, I am working on the doc.
I see. I কিছু দাও হ্যাঁ ঠিক আছে আমার জন্য ঠিক আছে গোল গোল চকলেট গুলো দিলাম খেয়ে গেল দেখি আমি বললাম না গোটা দেখা যাবে না
For recursion, I'm creating a doc like this. I will share with you all. Fine. Whatever code we'll do, we'll share here, right? So that everyone, whoever requires any help, may take it from here. Correct?
Yeah.
Okay.
And more or less, yeah. Give me some time, and so that I will be just uploading the video after today, and then give you the drive access here. Okay. Any ideas anyone has got? How would you solve this?
Yeah.
What you
Like-
what you will do?
I will go through the whole matrix. If it's matching with the current index of the word and current index of the board, then I will try the next, like the neighbor possibilities. If it's not matching, then I won't try any neighbor neighbor words.
Okay.
Yeah, that's the approach. I got
For a
I'll
particular
try.
letter, do I need to like? I have a logic actually. For a particular
May I
letter,
try,
have to
sir?
check right,
Okay,
left.
one by one. Yeah, Sajal, go ahead.
Yeah, like first I need to find out the first character of that
Yeah.
particular word. Okay, and then I need to find out that whether that word is like where it is first first occurring. So when I'm finding that one, from there I can trace from left, right, bottom, and down. Like
Okay.
I can use the recursive call from there.
Okay.
That is the approach in my mind. I'm not sure.
Same approach I thought.
Okay.
Yes, Sajal mentioned.
Can you go ahead and implement that? Anyone?
Yeah, like
Try.
I can try, like if you give as a homework, then I can try, and I'm pretty sure we can solve it. I'm not.
How many of you are sure you can solve this and would like to take this as a homework?
Yes, sir.
I can
Yeah, I
solve.
want it is as a homework.
Okay, let us have this as a homework. Fine. And we'll
Yes,
discuss it in the
Please.
next class positively. Fine. Even
Yeah.
I think the link is with you. Please take that as a homework. Come up with the recursive approach. And this is also more or less related to backtracking. Fine. The most efficient recursive ones you have to come up. Okay. And the previous question, any idea you had? What was the question, by the way? Array description. This one, right?
Yes.
Any idea anyone has? How should we go ahead with this question? What recursive approach? What recurrence you should come up with?
Means like here we have to avoid duplicacy.
As in? Okay, let me just open an IDE here. C++ IDE. Not this. This is a more DP related question. We have to solve it in a separate IDE. Yeah, tell me, what should we do inside this question? How should we proceed ahead? I think previous class we have already discussed the approach. How would we go?
Like basically, I read some articles on this problem on code forces, but I haven't got like I got one approach, but it's not at all matching, and I'm not at all getting the code forces articles
So
approach.
they will be more focusing on the dynamic programming approach, right?
Yes.
Yeah, they won't be giving you the so yeah, definitely they may come up with the recurrence, but you have to understand that a bit in terms of dynamic programming.
Yes.
How should we
Basically,
proceed ahead?
I my approach is like firstly I count the zeros. Then the base condition I will keep when I will count it as one possible array. When like zeros will be like count of zeros, I will decrease one by one whenever I will add any any number at 0th position, I will do the recursive call of two more possible additions in the specific index.
Okay.
Then the count of zeros will be like basically when I will count all the zeros, I will decrement where I had at the 0th position.
So
Then
what we
will be
require here, see,
and
what we
also I
require
will
here. If suppose something is 0, I need to fill this, right? And before here, let's suppose there is a number A I have previous to this index.
yes, sir.
So what are the possibilities here? Can anyone tell?
Specific number, last number.
It can be either A minus 1, A or A plus
Yeah.
1, if I'm not wrong, right? Is it?
Yes, yes, yes.
Okay.
Yeah.
So
Yeah.
considering all these options, I will try to frame my solution. So there will be corresponding to this 0, there will be at max 3 recursive calls. Okay, let us try to code it. Let us try to code it with some conditions. My voice is coming good to all of you?
No break, little bit.
Yeah, sometimes it's happening. Yeah. When, how many times it has happened?
Only twice right now.
Just one right now.
So int n, let us have a value of n and m as well, right? Two values we require, as well as let us have the array. And what can be the maximum value of array? Okay, let's test it for, the current n is equal to 3, m is equal to 5. Was it 5? Yeah, 5. Okay, yeah. Fine. And let the array be what? Let the array be what?
Sir, I haven't.
202, right? Something like this. What will be the conditions as per you? Let's frame the solution first, that void. And let me have an answer like this. How many answers are possible like this? So void possibilities. Or void what they required us to tell. Number of arrays, let's say. Number of arrays. Now next what we should do? What is my current index? I would just track that, nothing else. Nothing else I require, exactly. Now, what should we do here as per you? Tell me. If suppose my current index, or let's make it as IDX. That will be more better. If my current index is 0, then what we should do as per you?
Next numbers would be like I need to check.
Nothing really, right?
Like
If my nothing, let's suppose my index is 0, then what we should do? We can just check whether my current, and yeah, so first let's do one thing. If my index has already gone to the number n, have we reached till this point? Then we have got an answer for us. We'll say answer plus plus and return. Do nothing. We have already reached a place where definitely there is an answer. So let's increment my number and return. Now next what we should do as per you? If it index is 0, if I'm at index 0, and if my if suppose what should happen? Array of index is what? If it turns out to be 0, array of index is 0, let's say. I have to fill this, then what you would do? Tell me. How many possibilities can be there corresponding to this first index?
1 to m. 1 to m.
1 to m, there are multiple possibilities, right? With all we can definitely solve, if I'm not wrong.
Yes,
So what we should do here?
The next one, -1 or +1 can do, like the first index of -1.
So we can do one thing. We can try to go from 1 till m. Can try to place how many solution we have, right? How many solutions we have. If we can just assign here array of idx to be what? The value of I. And we can say, okay, now go and find out number of arrays from what? From index +1. First index I have filled up, that was 0. Now I will just call these functions. Go and try to find out whether this is happening or not. Now next what? If suppose it is not 0, we can just pass on, right? We can just pass on. We don't require anything else. We can just call this function. If it is else, then we can just do this. Or let us do one thing. Let's not keep it here. If array of I is anyways, the functions will be called. So if this is, then I will be just assigning a value to my 0th index and I will call this function. Because anyway, if whether it is 0 or not, I have to go and try finding the solution from index +1. Now, if it is non-zero, if it is greater than 0, else if idx is greater than 0, what we should do? Tell me. How we should go ahead, proceed ahead. How we should proceed ahead?
We keep track of the last element.
Yes, we'll be keeping track of last element. What we will do? We'll say if
it is 0, then last index +1, last index element +1 or -1.
Yeah.
And
So
thus
what
proceed.
are the requirements here? If array of idx is 0, let's first handle this. If it is 0, then what we should do?
Then idx -1, or we can maintain any variable of last element, or we can idx -1 also we can do.
Yeah, idx -1 definitely will be seeing that only. So we can
Yeah,
have
right.
function calls like we can have number of possibilities, number of arrays. We'll just do what? We can have first array of idx to be what?
idx -1 and
Array of idx -1. Then what we did? We called number of arrays from what? Number of arrays from index +1. Now next, what possibilities are left for us? Two more possibilities. Two more
Yes.
possibilities. One is what? Array of
-1
index. Array of index is equal to,
and
sorry,
+1.
I did. Yeah, array of index -1. It can be equal as well. Now next, another thing. What was that?
+1.
+1. But for this, I have to check one condition. What is that? For assigning this, I have to maintain one condition. If array of what? Index -1 +1 is lesser than equal to m, right?
M, yes, yes.
And then we'll be calling this function. Moreover, we should check for another thing. Have we missed something?
Should we check, like when we are doing -1, it will be
Exactly. That's what I
greater
was
than
saying.
1.
That's what I'm saying.
Yes.
That if suppose array of idx -1 should be greater than equal to 1, right? Then only we'll be calling this function.
Yes, yes, yes.
Yeah.
Yes, yes.
Now next what? These three we have handled, right? If suppose it is 0, then these three only will be handling. Next, what we should do? What do you think?
If it is any number, we should do that. If it's like element should be. If it's not, then the array is previously error array.
Then else, there is only one condition. It is
Not
non-zero. It is non-zero. It has definitely a number already assigned. This array of index has already a number assigned. So what I will be doing then?
Is it a valid, like I have to check that of current and the last one?
Yeah,
If
so I have to
the
check one
difference
thing.
is
If array of idx, if absolute value, right? Absolute value you need to check. Absolute value of array of idx minus
yes.
array of
IDX
IDX minus 1. If it
minus
is,
1,
if it is
1 greater than equals to 1 or 0, like
lesser than equals to 1, if I'm not wrong. 3
1.
possibilities,
Yes.
if I'm not wrong, right? At max 1, at most 1. That means lesser than equal to 1. Then
Yes, lesser
if
than
it is so, I will be going on to call what number of arrays? This function.
yeah,
So this is how my
IDX
recurrence will
plus.
be somehow looking like, right? If this
Yes,
is
yes.
true, okay. Any condition we have left? I don't think so. I don't think so. And by this, whenever we finish off, we reach to an index where it is equal to n. From 0 to n minus 1, we can fill. My index has reached a position n where no more index can be filled. I say, okay, one solution definitely exists for us. And we'll return from here. And let me try running this. Number of arrays, right? This is what? Okay, I will have to just what? Call this function from index 0. I need to... Hello?
Yeah, audible.
Yeah, and from this, and I will be just see out the answer. Let me try running this, whether we have done it correctly or not, or whether any code errors we have. Okay, so we didn't initialize the array good. Violation error. Sorry. Is the answer 3 for our previous question? For this example, 3, right?
Yes, sir.
We have done it
Yes.
correct. Okay, let's suppose I give all zeros. What should be the answer? What do you think? Let's suppose I take for 2 only. I say n is 2. M is also what? Let's say 2. A small solution will be checking all our zeros, whether we are getting it correct or not. Let's see. Answer is 2. Is it that?
Yes.
Should it be?
Between 1 and 2, there is only 2 possibilities.
Is it that? Let us just check. 1 is there, right? This is also a valid solution if I'm not wrong.
Yes.
Then 1 2, is it?
Yes.
Then 2 1, then 2 2. These 4 are the possibilities for us if I'm not wrong.
Okay. Yes. 4 possibilities.
So have we done it correctly anywhere, or we have gone wrong somewhere? What do you people think with the solution? One solution we are getting it correct. There is no problem. Okay, let me try to do one thing. Whenever I will be reaching this state, let me just print it. What are the solutions which are getting counted here? Int I equals to 0, I less than n, I plus plus. So what I will be doing, I will be just printing array of I. And post that, I will be printing a new line. Are you people feeling sleepy? Is it?
No. Not at all.
Okay, only 2 1 and 2 2 are getting considered here. Have we done something wrong? Just see. Why not 1? Okay, so one mistake. See here, we are not doing this. We have written something wrong. This was given to be minus. This should be plus. Okay, let me try running now. And I think we should be able to get the solution correctly. Is it happening? No, I guess. 2 1 2 2 again, 2 solution it is showing. Why is it so? we're not doing it correctly anywhere. Just let me copy this somewhere else.
You can full screen.
Zero. I need to check this whether this is, yeah, it's 14. Okay, sorry. So yeah, this is true. This is also correct. Something we are missing. What do you think? Any condition that we are missing here? By running it here, shouldn't be the case like this. Yeah, only two situations they are taking here. So once I'm coming to any function call, let's say, then what is my current state of array? Let us check that. Whether any function call is being made or not, let's check that.
Here should we make, where should we make, like each and every possibilities will be made to the call here. I don't know. Here, the 27th line, maybe.
Let me just see. Let me just debug it. Try to debug it once. So I don't know why it is also going for 0, 0. Okay, fine. So first time it has been 0. Why it is directly going from 2? That's what I'm not getting.
See, like the function call in iteration 27th line. Should we make the? I'm not aware of C++, but should we make the function call above in for loop?
Why I have done this is, suppose in any case it will be happening. Whether this array of index is 0 or not, that will happen. Just in case that you're okay, yeah, you're correct. You are correct. We are missing
Yes.
that. With each assignment,
Yes.
there will be a function
Yes,
call.
yes, that's
what we missed. Yeah. And also, if it is suppose not 0, then also if the array of index is not 0, then also there will be a function
Yes,
call.
yes,
Yeah.
yes.
Correct. Let me try running this and let's see what solution comes up. Okay, 4 solutions are correct.
Okay. Yeah.
Coming good. Let me try to just do this thing inside that. What are the possible solution here? So that all solutions gets printed here. Okay, 1 1 1 2 2 2 2. Why 2 2 is getting printed again twice?
Like again, the function call is happening downside.
One
after.
should it be? It should have been 2 1, not 2 2 twice. It shouldn't have been so. I think we are not updating the array properly somehow. Or maybe our global array is causing some trouble for us. Yeah, see, at this particular position, maybe Yeah, for this function call, once it has been turned to 2, for the next function call, it is not coming out to be 1. That's what I can feel of. Let's have a dry run. Let's have a dry run that why it is failing for us. It may be due to the global array. The array is global, right? It is to both are zeros for us in this case. Now, what is happening here? We start off with both zeros. We start by assigning here. This is 0, so we start by assigning it 1. Right? We start by assigning it 1. We want it to be 1, 0. So for the global array, what will be happening? It will be 1, 0, something like this. Let's suppose. And okay, what happens now? I go to fill this. I want to fill this. Then what can happen at this position? We go here and say that, okay, please turn out to be 1. So the inside the global array will be having it to be 1. Okay, 1, 1, this is accepted solution. It will go back. Now for 1, 2, I will be trying. For 1, 2, I will be trying and it is getting accepted like this, I guess. 2, 2. 1, 2, this is the current state of my global array. Now what should happen as per you? 1, 2 is there, it should go back now. So all the possibilities from here has been done. It will go and do one thing. It will start with 2 and it expects it to be 2, 0. Then it comes here. Now what should happen? It should have first explored 2, 1, I guess, and then 2, 2.
Yes, 2.
Are we not updating it correctly? Okay, one thing that will definitely be considered since we have already a 2 here, this function call will also be mattering. So yeah, what is happening is one error that we will be getting once we go on to explore is that once we come here, once suppose that there is a state, we expect it to be 2, 0, but we have inside the global array to be 2, 2. So this condition will be checked. One of the recursive function calls will be executed. That will be this one. That will be this one, right? It is already non-zero for us. At this state, we expect it to be this, but we are getting this. That's why our answer is not correct. We expect this entire thing to be executed when instead of that, we are coming and executing the else part. That's not coming good. Okay, that needs to be a little bit handled. The global array shouldn't be taken here. Okay, fine. I will be handling the code. The logic is fully correct. There is no problem. It's just that we require the array not to be global. Do you require it to be solved right now? Or can I give you the code later on? Whatever you say, that's fine for me.
Please give the code on later on.
Sorry? Hello?
For me, there is no issue that I got the logic. And also I don't understand C++ code.
Okay. Yeah, just we can do one thing. We can copy this array. We can just keep it inside our something. We can copy the array and we can try off like this. That's all. That will be sufficing, I guess. And let us, okay, sorry. Let me just copy this and let me paste it here. Keep the array like this and I will pass here. ARR. Let me try now and let's see whether it is coming good or not. Okay, fine. The recursive calls will be failing here because we are not passing the array. ARR. Let me try now and let us see what happens. Oh, it's not happening properly. Okay, I will debug this and we'll give it to you.
Okay.
Okay. Something wrong is happening. I will debug that and give it to you. Fine. So yeah, feeling sleepy, everyone? Is it?
No.
Fine. So we had a fairly good discussion today, I guess. Anyone felt bored or something like that? Please tell me.
No.
Like the class?
Yeah. Completely.